Alright. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Dan selamat pagi. Bagi memberkati program kita pada pagi ini, kita muli bacaan umul kitab Al-Fatihah. Ar-Rahmanir-Rahim. Ihdinas siratal mustaqim. Amin amin ya rabbal alamin. Mengalu-alukan kedatangan Profesor Rameh Sin, merangkap pemeriksa luar BDD Mechanical FKMP, yang juga adalah TNCAA Unit 10. Alright. So kami amat berbesar hatilah dengan kehadiran yang bahagia Prof ke Fakulti Mechanical FKMP UTHM. Yang berbahagia Tuan Haji Dr. Kamarul, Ketua Jabatan Mekanikal Fakulti Kejuruteraan Mekanikal dan Pembuatan. Yang dihormati sahabat-sahabat, terutamanya sahabat-sahabat yang dalam kelas state akademik. Alright, so terima kasih bersama-sama dalam program kita pada pagi ini. Saya juga mengalu-alukan sahabat-sahabat yang dalam online. Alright. So saya rasa kita ada buat live dalam YouTube. Okay. So hopefully sahabat-sahabat boleh pay apa ni orang kata, bagi komitmen lah. Alright. Dalam kita punya program pada pagi ini. Okay. So saya rasa tanpa melengahkan masa lagi, saya menjemput yang bahagia Prof untuk menyampaikan syarahan. Alright. Terutamanya dalam agenda kita pada pagi ini on the final examination question, level of the taxonomy. Alright Prof. So yang bahagia Prof, saya jemput.
Okay, terima kasih. Selamat pagi semua. Terima kasih Dr. Mubarak. Alright, so I'm happy to be here. I will speak in English. The lecture is in English. Saya akan campurlah English dengan BM sekali lah. So selamat pagi kepada semua. I'm happy to be here as the external examiner for program mechanical engineering, the Faculty of Mechanical and Manufacturing Engineering. Okay, my talk this morning will be on practical approach to setting final exam questions based on taxonomy level. Dulu saya pernah bagi I check my record, dulu saya bagi taklimat on complex problem solving dan complex engineering activities. Jadi kali ini saya tak nak repeat complex problem sekali lagi lah. So I think the other important aspect that I think as academic staff you should take note about is about setting the final exam questions based on taxonomy level. Sampai sekarang rata-rata mana tempat pun saya pergi universiti, saya tengok issue with many academic staff is that they when they set final exam question, they don't really think about the level of taxonomy, and they don't also, there must be a strategy when you want to set your exam question. And the Bloom's taxonomy or even any taxonomy out there like the solo taxonomy pun boleh pakai. But this lecture will focus more on the Bloom's taxonomy. Dalam Bloom's taxonomy, memang dia ada dia punya hierarchy when we set our exam question. The knowledge and the challenges that we want to set, we can use this taxonomy to help us with setting question. Alright, so this is just a short biography. The laser pointer dekat mana? Oh, yang ini. Okay. So just a short biography. I think some of you all know me. I'm currently dipinjamkan dari Universiti Melaya ke Unit 10, Universiti Tenaga Nasional sebagai Timbalan Naik Chancellor Akademik dan Antarabangsa lah, Academic and International. Sebelum tu I was also on secondment ke negara Brunei Darussalam, secondment ke University Technology Brunei as Professor Kanan or Senior Professor, and I was also the Dean of Engineering, Faculty of Engineering at UTB. So I was there from 2019 sampai end of 2022. Okay, so basically I have more than 25 years of teaching and research experience, and at I'm Professor Kanan, so JUSA A. Basically, I'm also the former Associate Director with the Engineering Accreditation Council from 2014 sampai 2018. So I'm familiar with the engineering accreditation, and I've done a lot of engineering accreditation as well as external examiner. So banyak tempat saya external examiner juga. So research I'm quite strong as well. So this is some of my research achievement lah. Okay, so I think you can see listed top 2% for 3 consecutive years. I completed about 84 postgraduate students, 40 PhD students from this number. I'm also a distinguished professor with 2 universities, Huang He Jiao Tong University and Northwestern Polytechnical University di China. I also visiting professor, banyak award lah, duit pun, research funds over the years 25 tahun kan, so accumulated almost $5 million lah. So these are not only me and my team lah, so they campur-campur lah, okay. I'm a fellow of the Academy Science Malaysia, fellow of IEM, fellow of IMEEK UK. I'm also fellow of Engineers Australia, Institution of Engineers Australia. I'm chartered engineer dengan Engineering Council, chartered professional engineer dengan Engineers Australia. I'm also a professional engineer locally. And recently, I also successfully obtained the ASEAN Chartered Professional Engineer, ACPE. Okay, so I have 4 a professional qualification. So I think academic staff as well with UTHM, especially for mechanical program, I think satu teguran yang you dapat, NC yang you dapat in the recent accreditation is about meeting the 30% PE kan. So I think that you need to move towards the direction of gaining the professional recognition. All right, so you cannot run away, because eventually, whether it's for accreditation, you need the professional qualification, because takkan you nak duduk sebagai pencara kanan rest of your life kan. So you want to move up the ladder, you want to become associate professor, and eventually you want to ended up as a full professor. Now that progression will look, especially from associate professor to professor, they will look at your professional recognition. Okay, you dah ada PhD, sebab tu you pencara kanan kan. You dah buat research dan sebagainya, so you dah naik ke Profesor Madya, senior associate professor, tapi nak ke professor ada 3 tangga kan, JUSA C, JUSA B, JUSA A. So the movement from associate to Professor C won't be as difficult as moving from C to B and B to A. So C to B, B to A, they look at your professional recognition. All right, so if you are ambitious and memang your PEO lah, kan kita cakap pasal OBE kan, so your program educational objective, so we all also have PEO in our life. PEO saya nak jadi TNC, so dah lah capai kan. So you will also have a PEO, your target, your aspiration kan, you nak bersara sebagai apa kan, takkan nak bersara as Profesor Madya ataupun Profesor Kanan, pencara kanan, so mestilah nak bersara as professor kan. So eventually you need to move towards that, okay, to get the professional recognition. And untuk mechanical saya memang boleh membantu lah, kalau nak charter melalui IMEEK ataupun IET saya boleh membantu, or IOM pun boleh. So I help a lot of colleagues to gain the professional status lah. So saya tolong tengok dia punya paperwork, cara dia tulis dan sebagainya lah. And then of course for BEM juga lah, saya banyak tolong kawan-kawan untuk mendapatkan kelayakan profesional lah. Okay, and of course my research interest is quite wide. I started my PhD is on advanced ceramics, and eventually I branch out to many different areas, joining, welding, failure analysis, and so on lah. Okay, so but my initial days I focus more on development of engineering ceramics for mechanical application, mechanical and bio application. Okay, All right, so this seminar, so ada outcome dia lah. So basically, it's to look at the taxonomy level so that all of y'all understand or able to apply the different taxonomy level. All right, when you set final exam question. Okay, so we will look at helps us as a guideline lah. It's a guideline that helps us to move from low level to high level. Okay, so why we set exam question? We know we have course learning outcome. I think some places call CO. I think in UTHM they panggil CLO kan, course learning outcome. All right. So we all know that when we when we look at our course outline, we always have the CLO. We have the CLO. We have the topics to be covered, but we have CLO. And CLO is always a combination of theory, what we want a student to be able to do. And that's what course learning outcome is about, kan? All right, so we have that. So we set the CLO, and then we base our activities and our teaching on the CLO. Now in outcome-based education, kita kena buat assessment juga. Because we have outcome, we need to assess those outcome. All right? So hence we need to do assessment. We need, especially for our program, it's very much heavy on cognitive. So final exam is always the main instrument that we use to gauge student understanding. I mean, whether student has achieved those learning outcome. All right, so we have final exam. Most courses, most core engineering courses, you have final exam, kan? So we know that we need to set final exam in order to check whether or not the CLO has achieved the necessary target. Of course, not all CLO needs to be assessed through tests or final exam. Some CLO is very much communication based. So communication based, kita tak pakai final exam. Some of them, if like project related, so we use assignment ke atau kita bagi case study as a gauge. But majority of the CLO for cognitive level would be test through final exam, kan? So we have to set final exam. Okay, so when we do that, just now I talked about the 6th level. We need to test the student based on their lower order thinking skill or LOTS and their higher order thinking skill or the HOTS. And Bloom's taxonomy can be categorized into those two categories mengikut dia punya level lah. So we can then set our questions to cover both categories, the LOTS and the HOTS as well. Okay, so we also need to understand. Yesterday also I discussed in our meeting as academic staff. We need to understand textbook questions are not final exam questions. They are not designed because they are not designed to fulfill your CLO. They are designed for drill and practice for a particular theory, for a particular topic in the textbook. Okay, so as we move on in our career as academic staff, we are called to design questions because we have CLOs. And our CLOs are not taken from textbook. We combine certain theory and we decide as academic what at the end of the day the student should be doing. They must demonstrate they are able to apply what to solve what. Textbook tak cakap macam tu, kan? Textbook teach on topic. Okay, so taking questions from textbook, sebenarnya the textbook are not really set at the highest level. They are more for drill and practice and to only focus on one particular theory for that particular topic. All right, so textbook question, they are not final exam question. All right, they are more or less they are for drill and practice lah. All right, so therefore there is a need to develop or create question. You kena design your own question. I think you cannot run away from that. So you definitely you have to develop or create questions to reflect your CLO. All right, because all the CLOs are different. You have 5 CLOs, for example, they are different, and so you need to design your question. Okay, and when you design your question, we want to test both the levels, the lower order thinking skill level and the higher order thinking skill level. Kita nak test dua-dua. All right, so in order to do that, that's where we use the Bloom's taxonomy, kan? And the whole idea is because, as you know, under Washington Accord program, we know that we have to ensure that we cover that aspect of complex engineering problems. So why we need to cover that aspect of complex engineering problem? Because engineers are called to solve complex problems. We want to have creative graduates. We want to produce creative graduates, kan? We want our graduates, UTHM graduates, when the graduates go out to industry, apa-apa problem dia bagi, the graduates can start from scratch. Kan? Sebab problem di industri is not textbook problem. You kena faham. I think most of us know this. Always problem in industry, they are not textbook problem. All right, so they are complex. There's no known solution. Textbook don't have answer. But we want our graduates to be able to apply the skill, the knowledge, right? The knowledge that they gain in order to come up with a viable solution. They can justify their solution. Kan? So that's why we need to ensure that. Then there's also this thing where people argue, boleh tak kita cover complex problem dalam final exam? The simple answer is yes, memang boleh. Yalah, WP satu kata engage with theory. So memang soalan tu dia kena pakai teori kan. Student have to use a particular theory to work out solution. So okay, WP1 dah cover. And then maybe WP2 talks about conflicting requirement. So boleh lah, kita boleh design question kata dari segi like mechanics of material, dari segi strength dan dari segi stiffness. Kita bagi dua conflicting, lepas tu student will find which would be the viable design, for example, kan, macam diameter of a shaft based on strength, then diameter of the shaft can be also calculated based on stiffness. But at the end of the day, there will be two diameter. So the student will have to decide which diameter would be the most viable, kan. So nak kata dah cover complex problem, memang dah cover lah. Sebab kalau ikut the definition, you have to have WP1, some or more of other WP. So maybe you want to add another WP in your soalan. So what I'm saying is that you can do it. You can do it. But the issue here is that the depth. The depth may not be there because time constraint. Satu soalan mungkin 30 minit ke 40 minit je. Alright, so complex problem can be used in exam question, but it should not be the main guide. The main guide should be the taxonomy level. So that's why I tell people don't confuse between complex problem dengan apa Washington Accord nak dengan the whole idea of the education taxonomy, especially when we are called to test student thinking skill. Complex problem is not about thinking skill. Dia tak sama kan. Complex problem, the WP tells the competencies. So saya tengok complex problem yang WP1 sampai WP7 is about competencies. What we expect our graduates should be able to embark on. But when we talk about the academic aspect, final exam, they are thinking skills. All right, so this is where you either use the Bloom's taxonomy or you use the Solo taxonomy. That is more appropriate when we are called to set final exam questions at specific level to address or to test the ability of student to apply their thinking skill, not the complex problem. All right, so you need to understand that. As I said, I am not saying you cannot do it. You memang boleh lah kalau you nak buat dalam you punya evaluation form. You want to have some mapping to show that question 1 cover what and all. It's okay. That's no problem at all. But that should not be the basis. Okay, that should not be the basis because the complex problem don't tell you at what level of thinking that you need to cover. It just tells you the characteristic that you need to fulfill, all right, in order to say that you are on complex problem, kan? Okay. So therefore, that's where we use taxonomy. Okay, so as I said, Bloom's or solo pun okay, tak ada masalah. Okay, I just want to share this report recently while I was in Brunei. We had the IMEEK accreditation. So very recent. IMEEK came, I think, sometime in August 2022. August, and then they evaluated the program, and then of course, we got the full accreditation lah, kita dapat. But we had some teguran lah, some NC, and one of them I just want to share lah. Okay, this is from the IMEEK panel lah. So as you can see, they said, so this is their exact word for word I extract from the report. Review the procedures for setting of exam questions to ensure that there is less reliance on a textbook style approach. I dah lama dah beritahu the program semasa saya external examiner sebelum saya masuk full time. I told them before, I was external examiner before for the program, and I told them that your questions are not challenging. They are textbook based. Okay, but you know, of course, when the EAC, I mean the IMEEK panel datang, dia pun nampak lah soalan tu tak challenging. So they said less reliance on textbook style approach, and that opportunity is given for a more open-ended style of question that will enable the students to be stretched and challenged, notably at levels 5 and 6. So dia cakap level 5 and 6, we understand lah, it Bloom's taxonomy level 5 and 6. So I acknowledge that this is a problem in the program. Because when I look at the questions itself, I see sometimes the question, I know from which textbook that the questions are taken. And the way how sometimes the questions are prepared, kita tahu lah, is memang textbook style lah. And so that's why academic staff needs to it takes time for you to be able to design your own question. So you need to develop. You can always based on a textbook question, but because your CLO covers a few different theories, so you need to find a problem that you are able to apply to develop the question to cover several theories at one go. All right, so you need to design question, and all of us needs to spend time. I spend at least between 5 to 7 days to develop questions for final exam. I never repeat my final exam question, because I don't want to be the talk of the town where student kata kalau professor tu semua repeat. Student will talk behind the back. You know, we all also as student kan, kita pun student. When come near exam, kita selalu bincang dengan senior kan. Senior say, oh that professor don't worry lah, he will repeat his question and all that. So tak sedap lah when student label you as a academic who does not you know, prepare your own question, that you are repeating question and so on and so forth. Under EAC, there is no rule stating if you can repeat question, but under Engineering Council ada peraturan dia. The Engineering Council has guidelines that states that you should have a gap of 3 years. So if you want to repeat your question, you may do so after 3 years lah. You may do so. All right, but I think most of the academic staff in the UK, they design their own questions. So I think we need to design our question, and the Bloom's taxonomy serves as the gauge, our CLO and the Bloom's taxonomy. So actually we need just these two as our guide. Okay. So how can we strategize when we want to set questions? So you can actually do a mapping of your CLO to what level of taxonomy you nak cover. Okay, so if you have 5 CLO, for example, so as I said, because you need to have a guide, so you need to plan. So you need to start at the lowest level, right? Lowest level, macam Bloom's taxonomy, the knowledge level. So the lowest level is you must have a plan. How do you want to set the question and at what level? So the easiest way is to have a mapping between CLO and BT. All right, so you can do this at the start of your start of the course or at the start of the semester, right? So what you can do, I give contoh macam ni. This is for dynamics. So you have your CLO, Okay, katakan you ada 6 lah CLO. As I said, not all the CLO, maybe these 2 CLO, dia tak pakai final exam. They are very much project based or maybe presentation dan sebagainya. Then you biar kosong lah. But what you can do is, if assuming that this is dynamics and all of them said I decided that I want to test them in final exam. So based on this mapping, to help me to set questions so that I don't, every time want to set question, I start to think, macam mana, what I want to do at what level dan sebagainya. So I come up with a mapping dulu. So I decide every semester how I want to set the question and at what level, right, for each of the CLO. All right. Nanti slide saya akan share lah. I will share the slide to Kamarul. So if I have this mapping, it helps me. So I know exactly for each of the CLO what type of question I'm going to do. So for example, if this one I'm going to say knowledge, so it's going to be question at that level. And for example, for the CLO 6, I'm going to set at the synthesis and evaluation level. So when I setting question with regards to this particular CLO, I know that the question must be at what level. All right, so this is a strategy to guide us, to help us before we start our journey to set exam questions. So you do this first, and then after that you proceed. Because as I said, setting final exam question is not like when the Ketua Jabatan send you an email kata, okay, the deadline for final exams question is when and when, then you just wait for 2 days before final exam, you ambil past question and you modify from there. It's not that. That's not the approach. In fact, setting final exam question should start as early as first semester. Normally mid-semester, there will be a call for submission kan, for final exam and moderation kan. So the good practice is to start it at the early. First week itself, you already plan. And then you got 7 weeks to prepare question. You can take your time. So you're going to set 5 questions. So you can take your time to set your question. Early days, when I was coming up as Pencara Kanan Associate Professor, I used to set question before the semester start. Of course, if the courses that I'm teaching are again and again repeating courses, then it's easy for me. So I normally set before the start of the semester. So during the break, normally you will have about 2 weeks, 3 weeks break. I spend that time setting questions already. But good practice to start setting question as early as possible. Don't wait until week ke-7 or week ke-8 baru you nak set question. Of course, when you wait till then, the questions will be all over the place lah, kan? So you plan first, you come up with the mapping. Dari mapping, then you decide, okay, at what level, and then after that you can slowly progress. As you progress in time, you can set the question. Okay, so this is something that can help you if you think that this is good. I used to do this all the time for courses that I'm teaching. Okay, when we look at the Bloom's taxonomy, there are 6 levels. All right, so I call it EAC lah, for easy to remember. We all know EAC kan. All right, so why I call it EAC is because I break up into three sections. I group knowledge and comprehension together. And we know that knowledge is the lowest level and then followed by comprehension. And we know that without knowledge, the student will not be able to comprehend. And sometimes also to set question at the knowledge level, you tend to cross over to comprehension. So it's very difficult to set the boundary between the levels. Memang susah. So the best way is we combine them. Whether you are knowledge, we use the comprehension as the target. All right, so knowledge is just memory recalling type question. Comprehension, they must go deeper than memory recalling. They must know a little bit about differences. So it's not just giving the name or remembering how to spell certain things, but in the comprehension, they need to go deeper, right? But before they can do comprehension, they must have the knowledge. Dulu kan? So I call that, I remember the C lah. So comprehension for me is that knowledge comprehension I group as one. And these are the lower order thinking skill. Lower order thinking skill is sampai comprehension. Then we move to the higher order thinking skill from level 4, level 3 onwards, right up to level 6. Now level 3 and level 4 both are A. Analysis is the higher level. Application is level 3, both A. Again, if we look at question, very difficult. Sometimes they cross the boundary. All right, so both A, so we label as big A lah. So either you do analysis or application, we said that you are meeting that middle segment of the taxonomy level lah. That means you are in a way challenging student to analyze. Okay, one is to apply, the other one is to analyze. All right, so we have the A. So I call it the A, and then after that, of course, the other one is the evaluation synthesis. So highest is evaluation. So again, we look at evaluation synthesis. Sometimes it's very difficult to differentiate them. So the E lah. So that's where EAC lah. So I always remember the EAC lah. So if you talk about the low level, lower order thinking skill, you are at the C level lah. At the C, which covers both lah, comprehension dengan knowledge comprehension, dia cover sekali lah. So that is lower order thinking skill. And perlu, in the exam, you should set question at that level too. And then subsequently, you set question at the A level, application and analysis. And normally you see, without you knowing about application analysis, most of us set exam question at that level. Okay, at that middle level, without understanding this Bloom's taxonomy dan sebagainya. But it is the E level that we are always, we are not sensitive about. Okay, we are not sensitive about setting question at that particular level. All right, the E and the synthesis and the evaluation level. And that takes time. All right, this is where when we as auditor, we want to look at least in the exam questions that you set, at least there are question is testing student at that high level. And you can see we don't talk about complexity here. We don't talk about complexity. Someone asked me before, is there any correlation between the complexity and the thinking skills? Sebenarnya tak ada lah. Because the complexity, Washington Accord define the characteristic of complexity. Dia tak define the thinking skill. There's WP1 to WP7. They are different competency or characteristic. Dia bukan kata at what level of thinking skill. So that's why I see some university or some program when they set exam question, they don't use Bloom's taxonomy, they use the complex problem. I feel it's wrong. Because it's not, exam question is set to test the thinking skill, the ability of the student, right, as far as thinking skill is concerned. So we should be on the taxonomy, not on the complex problem dan sebagainya lah. Okay, so there are 6 levels, so we know EAC. So our target is always the E. And of course, when we set question, we are not going to set all the question at E level. Kita ada 4 soalan kan, student kena jawab. So we balance it out. At least one question or subsection of questions are covering at the E level. Okay, at the E level. I was yesterday we had some discussion. I said that if you study in the UK normally if you have to answer 4 questions kan. Normally most students can answer 2 questions. Sebab the 2 question is always up to the analysis level. Bagi soalan macam tu, bagi parameter, okay, apply, okay, no problem. So first question all can do 25 marks penuh, memang senang nak dapat because the test is at the C level. And then the other question will always be at the A level. Okay, the application analysis level. All right, and most students can do both these questions. So that means the student can pass the course. And then the third question is where the challenge starts to come in. It's a combination of analysis and synthesis. And then there will be one question that is at the highest level, the combination of synthesis dengan evaluation. And normally the British style is that they only the first class yang boleh jawab 4 soalan. And most students will cover 2.5. Second class apa sampai 3 boleh lah, or 3.5. So I know when I was a student there, I got first class obviously, but when I look at all the questions, how they set, I can see the pattern. Okay, I can see the pattern of how questions are set, and I also do a lot of past question, textbook question. I think for almost every course I maybe do on my own tutorial, maybe 300, 400 questions, all textbook that I can find relating to the particular course. I would go and photostat, and I practice. Sometimes I take 5, 6 days to solve one question, but it did not stop me from continuing to think and so on. So I cannot do, I keep aside. Okay, and I always say that this question are man-made. So there is a solution, right? So I challenge myself. All right, and that's what we really want to develop, that skill in our students. Right, we should be giving them examples and tutorial questions that is covering the hots and the lots as well. We should give them high level question when we give them as tutorial. If not, if you just introduce in final exam, they get a shock. Dia tak nampak soalan macam ni tiba-tiba keluar final exam. Then dia cakap, sir you never teach, ma'am you never teach. Susah. And kadang-kadang pelajar kita kan, dia kalau you ajar static, they expect that the question should be within this boundary only, static. You cannot take from the subjects that they have went through previously, like from physics. Your critical thinking. Every parameter given, you have to see kan, you have to see and you got to apply them. Like for example, moment of inertia or finding centroid. For mechanics, for mechanics. This you study at lower level, but when we go at design, student kena cari centroid of a structure. They don't know. They don't know how to find the centroid. Even if they forget, if they have critical thinking, they know how to go about in finding it. And that's where, when we set question, tutorial question, we should also challenge them. Bukan dari textbook je. Kalau pakai textbook, that's it. Textbook is confined within that particular topic. And then student expect question to be textbook. Okay, so this is where you need to think differently when you come, when you want to set exam question. And I also always encourage students to go and look at the past question, past paper. Most students, they don't really look at past exam question. And we have to tell them. So they don't have strategy tau. As a student, they themselves, I find sometimes they don't have a strategy. Okay, to how they want to learn and do well in the course. When I was a student, tak ada orang ajar saya, but it's my strategy. The first week, library, past question, 10 years, apa yang saya boleh cari? Answer I tak nak. I don't want the answer. Today student even know the solution manual. Masa I was a student, I didn't know solution manual exists. I really didn't know. But for me, answer is not important. All the questions are solved. I've never checked the answer. Okay, I never checked the answer. But basically, I take the question. Every time a particular theory is being taught, when I do my revision, I look through past paper. For my daughter also, same strategy. Di Brunei, we took the past question for her PMR Standard 6. I went and bought all the past exam the question lah, PMR question. And kita nampak pattern tau. We can see pattern. If you analyze, so if student is listening out there, if you take past papers and you analyze them, because you do them, you can see a pattern. You may find that some questions repeated every 2 years. Same question, every 2 years they repeat. Or you can see a particular area is being focused every year. So then you are prepared. You are prepared, you know that, okay, I know this year what is going to come out. So it's a strategy again. So students should be informed that they need to take the past year. And this put the pressure on us. When we tell students to take past year question, we know already we cannot repeat question. Because student dah tengok past year question, takkan you nak repeat question kan? So you can't repeat. But because you know you're going to design question kan? So you're not worried about that. Alright, so these are the 6 levels. So EAC, so it's easy to remember. We know EAC, so whenever you think of EAC, so you know that it also relates to the taxonomy level. So E is the highest level, C is the lowest level lah. So when we set question, actually there are only 3 different grouping that you need to focus. Because when you give knowledge question, you will cross with comprehension. Right? So you don't only ask to define, but you also ask to explain. So that is the lots level. All right. Then you go into the A level between application and analysis, and then after that the top level evaluation and synthesis. Okay. So lots level, I mentioned this already. Aims of lot level to evaluate student preparation and comprehension, diagnose students' strengths and weaknesses. So basically is to test their very general skill of understanding, comprehend certain theory and so on and so forth, because that level is very important before they can move up to the next level. All right, so if they cannot comprehend, they don't know what a hammer is used for, they don't know what a certain theory is good for, or certain device is used for, it's very hard for them to move on to the next level. Okay, so this is at the lowest level. And then of course we have the HOTS level. HOTS level cut across the 4 level, so right from the application, analysis, synthesis and evaluation. All right, so any level, as I said, most of us we set question just at the A level. Very few of us would cover the E level, because we don't know how to design question, or we don't want to spend time in designing question. Okay? I just showed this slide just to show the difference, because I've given similar talk in the past where people ask about solo taxonomy, right? So solo taxonomy, so this is the hierarchy for solo by BICS. So BICS came up with this taxonomy. So basically it goes from also 6 level, 1, 2, 3, 4, 5 level. All right, so the highest level which covers the evaluate synthesis is called the extended abstract level. Okay, so it's the extended abstract level. But as I said, the spirit of the different levels is the same. You have the lots and you have the HOTS, right? So in the solo taxonomy, it goes to unistructural, identify name, follow simple procedure. Then the next level, at the C level, multi-structural. So they are same. When you start at the lowest level, it's just single structure. As you go up, you are required to understand multi-structure, right? And then after that, it goes into the A level. They call it relational. So how you can relate what you have obtained at this particular level, to relate them. So to apply and to analyze, can. And then after that, it goes right to the top, extended abstract. So this is where you hypothesize, you reflect, you give reasoning, dan sebagainya. So the spirit is the same, all right? The spirit is the same, whether or not you use the Bloom's, the original version, or the latest version, or the solo taxonomy. All right, all this taxonomy talks about the ability of students to progress from low-level thinking to high-level thinking. They are not about complex, right? They don't talk about WP1 to WP7, right? They don't talk about that. They talk about the thinking skill, all right, ability to progress, right from knowledge right up to the ability to justify and to argue. All right, so you give a question, they need to argue their approach, why they have taken that approach, and they need to then to justify why the solution is viable. Normally questions at the highest level always, sometimes there's no right and wrong answer also. It's the approach taken by the student, and if they choose the wrong approach, it's wrong, because they lack the lowest level. Right? So sometimes like in thermodynamics, you can ask for a crazy efficiency. You can give them questions that you know that if the student understands the principle, the student will be able to say that, although the student work out the answer, and the student will justify and say that this design is not viable because, right? Because it goes back to the fundamental, the theory. But if the student cannot articulate the proposed solution, then we know that, okay, the student is only good at the analysis level. So setakat analysis, no problem. But beyond that, the student are not able to demonstrate that higher level. And that's where you distinguish between that second class upper dengan first class, because first class student normally they are able to apply their thinking skills, and they are able to rationalize the answer and so on and so forth. Okay, so I think to be fair, when we mark our student script, we need to have that boundary as well. All right, we need to be fair to the students that work hard, okay, that put a lot of effort dengan yang average lah, you know. So that's where the taxonomy helps us to segregate those the different levels of questioning lah when we ask. Okay, so now I'll go into each one of those levels so that we can understand. Knowledge, as I said, is the lowest level. It's the lowest level is basically they know about it and they are able to recall it. That's what knowledge is about, memory recalling lah. Okay, so that's what knowledge, and I think it's very easy for us. It's a level of remembering, recalling, and restate, right? So knowledge represents lowest level. Nevertheless, it is important, of course, because if they can't recall the right tool, then they will not be able to move to the higher level, because they don't know the tool, the name of the tool also they don't know. Okay, so when they don't know the name of the tool, how can they then go up and to the next level to propose solution using that particular tool, because they don't know first the tool, and they may not even know what the tool is good for. Okay, and these are some, if you check in the website, there's a lot of verbs that you can use, okay, to help you to phrase your question. And these some of the verbs that you can use: cite, count, define, draw, list, name, record, repeat, dan sebagainya lah. Okay, so these are some example lah. Okay, at the knowledge level, right? At the knowledge level, like define what's Newton law is about, state the second law. So what is pre-stressed concrete? State the difference between covalent ionic bond. Define metallic bonding. List 5 pillars of TPM. What does the Kirchhoff voltage law states, that kind of thing. So basically they recall back, all right, and that's important. That's very that's required even at the degree level. But of course, when we set questions like this, we don't give a big portion of marks, maybe just 2 marks, 5 marks, you know, just to get them into the mood, and also to help them to because question, you must understand, some students get anxiety attack, you know, when they start exam, they look at the question, they dapat the panic attack. So sometimes part of the strategy is to go easy with the question, so that student gets into the mood, they start to think about it, and then as you progress to the next stage, they start to get warm, then they are able to do the questions within the time allocated. Kalau tidak, jam, kan? So sometimes it's a strategy as well, but it's an important level that we need to test student also. Okay, it's an important level. We can't have all our question set at the E level. We can't. Kalau nak boleh, tapi if you will probably have a high percentage of failure rate lah. All right, if you do that, and that's not correct also, because you are not. Remember, you have the CLO. right? You remember you set the question based on CLO. So strategy dia dah ada. So during accreditation, for example, if a panel talk to you and ask you how you strategize in setting your exam question. I kadang-kadang, sometimes when I do my A-level, evaluation kan, I tanya pencara when I interviewed, when I was a panel, what's your strategy? How you strategize in setting question? I nak dengar. And very few of them talk about CLO. Very few. Okay, they will say, oh, I know what is important, which topic is important, so I set according to that. This is common answer. But the actual answer I'm looking for is that to tie up with CLO. It's not about what you feel that you want to test the student. You have agreed on a certain outcome. All right? And that's where if you start early, you put the mapping, the CLO with respect to the BT, Bloom's taxonomy, or solo taxonomy, up to you. So if you set that level, it's very easy already. You know what exactly you want to set at what level, isn't it? So it's easy for you. And when anyone asks you, you say this is the strategy. So yesterday also I discussed about complex problem. You must have a strategy, how you want to address the WP 4, 5, 6 and 7. Okay, WP 1, 2, 3 senang. Mana-mana boleh cover. Okay, but WP 4, 5, 6, 7, not all can cover. So we have to strategize, right? The next question is, do we need to cover WP 1 till WP 7 in our program? The answer is yes. You need to cover all the WPs because that's all the characteristics that constitute or make up what complex problem is about. Just like in complex engineering activities, there's EA1 to EA5. Many people focus on EA1 or EA2. But what about 3, 4, 5? Is it not important? The answer is no, it is. It is important, right? But you must strategize because some of them cannot be covered in all normal courses. They have to have projects. So wherever there are projects, we have that specific complex problem and complex engineering activities. Okay, so comprehension basically it's a level above knowledge, right? So they are able to explain. Normally at the comprehension level, we expect students they have grasped the knowledge, they know about it, and they are able to then explain it. Okay, so not just memory recalling. All right, so just like when we teach our children of certain things, when we teach them, we don't want them to just memorize and say it out. We want them to also understand why this is good, why that is bad, for example, or why we choose this and why we don't choose that. So we want them to understand some of the advantages, disadvantages as well. So the comprehension, so not just memory recalling saja lah, okay? Right, so at this level, we expect students to be able to interpret, identify, and use appropriate theories to solve problems. So they already know all the different theories, right? They can recall, they can memorize the formula and so on. So now they need to comprehend, they need to understand what are the limitations with each of these theories. And then once they have that comprehension, they are able to apply this in solving problems. That's when they go to the next level, the application part of it. So you can see without that comprehension, they cannot apply. When they can't apply, they cannot analyze. They'll be stuck because they use the wrong formula, and then they comes to analysis time, they are stuck. So you can see that there is a sequential process here. All right, these are some keywords, verbs that you can use: compute, describe, dan sebagainya, discuss, explain, express, identify, locate, and so on. So examples: compare the main difference between thermoplastic and thermosetting. So earlier you asked them define what is thermoplastic and what is thermosetting, so they can define, right? So they have the knowledge. When you talk about comprehension on the same area, you ask them to compare. So now they need to understand behavior when they are subjected to heat, for example, all right, or loading. How would they behave differently? And so this is where, and then the next question is why. Okay, why they behave differently. So this is where comprehension comes in. All right, this is where comprehension. Why metal, for example, can conduct electricity. So I try to explain to my daughter. She's learning now conductor, metal, and plastic, right? And the school teacher don't tell them that metal can conduct, because metal has a lot of free electrons in the structure. It goes back to structure. It's the structure that dictates the characteristic of the material. So I tried to tell her, and she said, no, my teacher didn't say this. So this is where I thought to myself, if the teacher don't understand what are the main difference between metal and polymer, and why metal can conduct electricity, susah. It's because they have a lot of free electrons in their structure. They can carry electric. Cakap macam tu. That's what the ketua jawatan tells me. The student have forgotten why ceramic cannot conduct electricity. They are not able to relate from the structure point of view. You see or not? So this is where, if you look at the progression, the sequential learning, if this does not take place correctly at the lower level, then when they go to higher level, they kata ceramic pun boleh. Polymer also can conduct, no problem. And that's what our student will say. So that's where we need to ensure that at this level they get it right. These are some examples, compare, explain the effect. So this is where the keywords you talk about: explain, discuss, express, dan sebagainya lah. A solid stuff is to transmit what would be the diameter if it is not to twist. So you can ask question, what if, for example, to state their comprehension, right? So they know which theory that they need to engage with. Adalah banyak examples lagi. It is always necessary to be concerned about the effects of biaxial stress. When can biaxial stress be ignored? So when can we ignore biaxial stress? So if the student don't know what is biaxial stress, they don't understand. When can we ignore this in our design? Right? Do we need to always consider it? So that's where comprehension comes in. Illustrate, setup, explain, dan sebagainya lah. Okay, third one is application. So now we have seen the comprehension, right? So I hope all of you all understand at that level. So now we are moving to the A. Now, application and analysis, that's why sometimes when I read through exam paper and I have to decide whether it's an application analysis, I normally just give it as analysis, the level 4. Because if you read the question, when you look at application, just now from comprehension, now you got to apply problem. You apply your theory to solve. And for engineering is easy because we will have to give a certain question relating to an application part, and then after that it goes into analysis. Then you give the question, then you say that to obtain efficiency. So students have to go through that process of application and analysis because applying the right theory, and then after that analyzing the data given and getting the answer. So application and analysis always go together. For engineering, as long as engineering per se lah, it always goes together. So it's very hard to separate both of them. All right, so basically student at this level be able to apply or use learned concept or theories or information to solve a problem within specific boundaries. So we throw problems to them, but we set the boundaries. So it's not open-ended. Boundary dia dah ada, answer, there is an answer for it. And based on the boundaries, if the student have good understanding, knowledge and comprehension, sometimes the boundary will limit to what theory they can use. Because they look at the boundary, they know that this theory won't work. They can only use this theory. Because memang CLO, based on the CLO, you target for that particular theory. All right, but you want to confuse the student, you set boundaries, kan? So that's what you do. So student will have to decide which are the theory can be applied. So that's what application is about. All right, so if you look at this, like the first one is a static problem, but this one we said already, apply the principle of work and energy to solve a particular problem. So these are application problem. All right, so we instead of setting boundary, we tell them what theory to use. All right, so apply the principle of work and energy. Calculate the number of bolts required. So we give them a scenario. We ask them to calculate, for example. So they apply specific theory, right, to obtain the answer. Select the most economical beam. Okay, so you give certain things, then you tell them what are the flexural stress. So you set boundaries, right? You set boundaries, and you tell them whether you want an I-beam and the other is a wide flange beam. So they decide. So you give two scenario, you give the boundary, then student decide. So student apply theory, and based on the parameters, they use one of the parameters as a gauge, for example, and then they test the understanding, whatever they know, they apply, then they are able to tell which beam would be most suitable for a particular design, kan? So likewise, we have this one, this question. So you give the scenario, the boundary, then you give temperature and so on. So a lot of information are provided, and then you said calculate the heat transfer coefficient by using, you give the two equations. So basically it's applying, right? They're applying. So applying those equations with the boundary conditions given, the data given to obtain a particular answer. All right, so a bit more lah, you know. So you have this a feed water extract, determine the second law effectiveness, how much work was done in moving a 10 kg boulder, and you know, and so on and so forth. So these are all typical application type question. And sometimes when we look at it, it can also be analysis. Okay, it can also be analysis, but normally analysis goes a little bit more deeper. Okay, so in this case, when we talk about analysis, student understand both the content and structure of the material. Student be able to break problems, either information into parts. So it goes slightly deeper. If you look at all those questions just now, it's basically setting, giving them certain data and telling them to use a particular theory, or without telling them, they know based on the data given, they know which theory to apply. But when we talk about analysis go a bit deeper. So sometimes student will need to break up or use information from like a power plant, for example, right? Power plant is a good example. So they use information obtained from the first part of the analysis into the second part. So what they obtain first, they apply to the second part and then to the third part. So they are able to analyze the problem. All right, so it goes slightly deeper. So in analysis type question, we ask student to identify, to analyze, of course, to reach a particular conclusion. So they normally have to break up. And normally, analysis is a system problem. All right, you give them a big problem where they will have to go. You want to see iteration. That means they first start with a certain analysis from the beginning, and then they move on in order to obtain the final answer. Like for example, in a power plant, we ask them to find efficiency. So eventually, efficiency ties to the pump, the compressor, then you have boilers, then you have turbine. So you have 4 different components there. And student will have to analyze from the time the steam comes in and right to the time when the steam goes out. And what would be the power generated, what would be the heat loss. So the student have to go through that iterative process, right, in analysis. All right, so these are some example. A rectangular beam is designed to support various loads as shown. Okay, so you have a diagram. Determine the flexural stress in the beam at all points where the stress is 0. So here it goes to higher level. Although it looks easy, simple question, but if students don't understand, determine the stress at all points where shear is 0. That's all you tell them. You give them a loaded beam, and you tell them that find the stresses where the shear is 0. So it goes right down back to their knowledge, their comprehension. Kan? If they don't understand that what the term simply means, then they'll be stuck. They'll be staring at the question for half an hour, right? They won't know what to do. And of course, when you give a beam, they will have to first work out the reaction at the beam, right? After the reaction they obtain at the support, then only then they move on to the next level, right? They want to find flexural stress. The next level, they probably have to draw their shear force diagram. Only where the point where the shear is 0, then they go back to the free body diagram and determine the bending stress. They apply the bending moment equation, they derive it, and they take moment at that point, then they find the bending moment. Kan? And then only after the moment, then only they can apply the bending equation to find the bending stress. So you can see there's an iterative process. It's a structured iterative process where they will have to go through. And our marks will go according to that, our marking scheme. Isn't it? That's how we set the question at analysis level. So at analysis level, a lot of it, they are tie up. They are the process that the student have to go through is normally an iterative process. Okay. And likewise, you can go with the other questions as well. And normally, as I said, when you look at both, you can also argue just now the question, given boundary question, to use the principle of work and energy. Pun sama juga. Right? Of course, they know the theory. Some parameter may be missing. They will have to determine first a specific parameter, and then only apply the principle of work and energy. Right? So sometimes people can argue that applied type question also cross to analysis juga. Okay, but normally analysis is deeper. And as I said, all of us, when we set exam question, we are always at the A level without realizing what we are doing. All right, we are A level. All the CLO is at A level. All right, and of course we set part A, part B, part C, so that's where we have normally part A 2 marks, 3 marks at the comprehension knowledge level. And then part C, we go into the A level, right, the main level. All right, some more example. You give a scenario. or it can be analysis, depending if there is an iterative process that the student have to go through. All right, so same thing, Rankine's cycle is given, so you give that, determine second law effectiveness. Okay, so first part, simple lah. So memang ada analysis here because there's a lot of component involved, and the student will have to go through that process in order to find effectiveness. And then after that, you can add on. What can you conclude about the factors influencing the second law effectiveness? So you can always ask opinion. You want to test. Actually, the second one basically is based on what they get here and their understanding. So you are crossing between the middle level and the lower level. All right. And here analysis comes in because you give a lot of parameter and you said makeup water is supplied as saturated liquid at the condenser pressure and saturated liquid leaves the condenser. So there are analysis here. All right, they have to understand what does that mean, and then they have to analyze that condition of the steam, right? And then after that they must know where to find the data, right? They use steam table, whatever table necessary, and then after that they solve the particular problem. So they find whatever parameter they need to find. So there is that aspect of analysis in that particular question. So likewise for this one, deduce the equation. So prepare a particular relationship. The first part is to understand the question and then to come up with a mathematical relationship. So they analyze the problem, come up with a mathematic. After that, they apply that mathematic relationship to solve a particular problem. So the last part, normally we give 5 marks lah. Because if they got the equation correct, they only need to apply kan. So kita bagi 5 markah. I remember in the UK, when the question involved derivation, 20 marks is always for the derivation, 5 marks for the answer. Because we apply it already. Because we already derive it, then we apply it, right? So the bulk of the marks go for the derivation. Okay, so same thing, analysis type, find the safe talk that can be transmitted. If the angle, so here then you give another scenario where you want them to do analysis. You say that if the angle of twist is the same for each portion, what would be the length of each section? Is this a viable design? All right, so there's analysis involved. It's not just applying theory, but the student will also need to look at the context of what the question is asking, and the student will then have to decide whether it's possible or not possible. So involve some analysis lah. Okay, so same thing, analysis. The first part is straightforward, determine maximum power that can be transmitted. Second part asks you if the fillet of the shaft, the radius is changed, right? So what will be the percentage change relative to the initial design, right? So student will need to think about how they find percentage change. You did not teach this in the class. What will be the percentage change? This they learn somewhere else, right? They find new answer. They got the original answer. They take new answer minus original answer divided by original answer, right? Get the percentage. But you did not teach them. Student cannot do. Student says, sir, you never teach. Because you did not put it in any example in the class, or you did not put it in a tutorial question. And this is where in the UK, all the questions we see never be seen in tutorial at all. All the questions that we normally get in the final exam is first time. Right? It's first time, and we don't know. We don't know whether we are on the right track or not on the right track. Right? Because you know, they really want to test your understanding and your thinking skill. Okay, so I've given more. I'll skip this. More analysis. All right, so synthesis and evaluation, they are at the higher level. What time now? Oh, 10:30. Okay, I better speed up. I don't want to take too much of time. Okay, so when we talk about synthesis, as the name implies, normally they put theories together. All right, so normally they can be a system problem, and normally they bring in 2-3 different theories to solve the problem. And this is where synthesis is about. Okay, so they piece things together All right, so combining concepts and theories. So this higher order question expects students to exercise critical or creative thinking. All right, and this one you can do normally for at the higher level courses like at the year 3, year 4 courses. We expect questions to be at that level, right? I remember heat transfer. I used to get 1-page long question. 1 page in the UK. It's very common that they set 1-page long question, and you read, everything is connected, and 2-3 different theories are applied. So answer from first section is used to the second, you use into a different theory, and then you finally come to the last one. Macam tu, so 1 page long. So that's very typical. If you look at thermodynamics by McConkie, the textbook, soalan dia semua panjang-panjang. You know, I think most people use Chengel and Bolt for thermodynamic, the American textbook. That one short questions. But you try to look at the British one, McConkie, for example. Long questions. Very typical, very long questions. All right, so a lot of it are, you have to engage with different theories when you solve questions like that. And that's synthesis level lah. Okay, that is. They have to propose a particular design, and they have to then deliberate on that particular design. So they may bring in different components. They have to suggest, right, different components to be put in, because that's why you say propose design changes can. So they have to do that, and then that's where when the student explain, the student understand. When you bring in different components, you have different theories that you need to engage with. So likewise, question like this is something on a bit on vibration. So you give specific state where, okay, the first one is basically maybe comprehension lah. You want to know where the nodal point would exist. So you give them certain things, you give them these parameters. So they say state where do you think the node point might occur at the fundamental frequency of a torsional oscillation, and hence determine this frequency. So based on what is given there. Then the second one said it is proposed to lower this frequency by 25%, redesign the system. All right, so they will have to piece things back together, because you want a design that be able to give you an increase of frequency by 25%. Determine the magnitude and provide the dimension sketch of the fundamental mode of the 5-rotor system, right? So questions like this is at the highest level, right, synthesis level. Whenever you ask them to propose or come up with a new design or propose how they can make changes to the system, so this is where you expect students to go into that high order thinking skill. Okay, so this one, another one, a simple problem. In a design, a solid shaft of 150 millimeter diameter is to be replaced by a hollow shaft of the same material with internal diameter equal half of the external diameter. Propose the design of the hollow shaft and determine the saving in material. State any assumptions made. This is from University of Cambridge. Okay, in one of the question. I tried using this when I started my career. Nobody could answer. Just a question just like that only. All right, so there are a few things that the question asks. Okay, they want to know what is they say proposed design. So they want to know what is the design. So hollow shaft there, diameter lah. That's what they say propose the design kan. They don't tell you anything else. They just stop short, just saying that, okay, diameter for the hollow shaft, the big D is half the small d. The small d is half the big D, equal half of the external. Okay, that's it. Propose the design change and state any assumption made. So this is a final exam question in University of Cambridge. When I did my past year question, as I said, I stuck, took me a couple of days. I have to look at it, I have to think what is common between both, what is not given, what I need to assume, dan sebagainya lah. And then the second part said, what is the saving in material? So macam mana nak cari saving in material? From solid replacing to hollow. Kan, saving in material. So saving in material, we need mass. We need mass, kan? We need mass. But mass not given. So that's what came to my mind. No, I need mass. They don't give me mass. So I thought something wrong with the question. Then I said, cannot be. Then I read on, they say same material. So the key is there. Same material, kan? So what must be, what else same? Density same, kan? Whether I take that material, I make into a solid, I make into a hollow, same, isn't it? So there's no difference in the material. So density same. So what changed is volume only. Now for volume, I got cross-sectional area. Solid, hollow. What about the length? So state any assumption made, kan? So this is to replace shaft. So if I have an application, obviously the length from the motor to the turbine, for example, the length is not going to change. I'm only changing the shaft only, isn't it? The hollow and solid. So L remains the same in both cases. So things like this, where you expect student to think, isn't it? You expect student to think about all this. So if you give in a final exam question without covering this aspect in the class, student cannot do. So this is where only the first class, I realized that this is how they segregate the first class student. Because first class student look at it, they are able to think, put down their critical thinking, and then be able to solve. This final exam, exactly, this is a final exam question. Okay, so this is high level lah. This is high level lah. Okay, it's at synthesis level. Okay, so there are many others. So evaluation is the highest level as far as Bloom's taxonomy is concerned. Normally, evaluation asks for judgment. Okay, that's where you need to make some decision. And normally, this type of question can be design-based question. Design-based where you give them scenarios, you give them conflicting parameters, and then let them engage with those parameters, and then let them decide. So, for example, finding diameter or finding efficiency can be done through 3 different ways, and let them decide. Okay, which is the correct and why, right? So that's what evaluation level is about. And again, as I said here, justify. They need to justify. Again, evaluation level, sometimes there's no right or wrong answer. The right answer depends on how the student defend the punya justification. Right? That's the right answer. So you read what the student says and how the student justify, because that is a judgment of their understanding, their critical thinking. Right? So that's where you judge them. So sometimes there's really not, you don't have a right or wrong answer. It is an open-ended. Let them to decide and let them to argue. And of course, they need to argue based on sound principles. Right? They use theories that they have learned, not pluck some ideas from the air. They have to justify with theories that they have learned. And so they use that. Just like in IMEEK, when you apply for, if not even IMEEK with IET, they ask you how have you engaged with engineering theories, one of the competency. You must cite examples. And those who do PhD is easy. You can always say in my PhD project, then that's where you said what theory dan sebagainya, so they know. So normally for that competency, the first competency they ask, how have you engaged with engineering theory? Those with PhD, you can always relate your PhD work. But of course, just relating, if you've done your PhD 10 years ago, takkan 10 years you tak buat project kan? So you can also say in another project that I was the project leader. Then you explain a little bit, and then you said, how have you engaged with engineering theory? I use what theory to obtain what, dan sebagainya kan. So, when we talk about evaluation, evaluation needs to go that depth lah, reflection, justification, dan sebagainya. And as I said, sometimes there's no right or wrong answer. We leave it open. All right, and we can throw in maybe 5 marks, 10 marks for evaluation-based question. Okay. All right, you give a scenario, and then you say which of these options would be preferred and why. So you give conflicting requirements. So macam complex problem lah. Complex problem, you got conflicting requirement. But here the student needs to engage. They need to know which theory to use. They need to engage with those theory. And then there's always the different ways or approach to obtain the answer. Then they have to justify. Okay. Appraise the results. So this is something to do with overall equipment effectiveness, right? So OEE, those who teach manufacturing technology, you know about OEE. So you give them a scenario, then you ask them to appraise. All right, so to appraise what does the OEE value obtain, whether it is viable, if it's not, what are the areas that they think or where they think improvement should focus on dan sebagainya lah. All right, so recommend change. You can give a scenario of an experiment, for example. So this is a physics question. You give a scenario where the theory says that he should be able to go to a certain should slide 2.5 meters, right? So based on theory calculation, it should go that distance. But when the student actually perform the particular experiment, it doesn't meet that length. All right. So what went wrong? Right. So recommend changes. So now you expect student to redesign the experiment, right? So that it should follow what the theory says. That when we release the particular wooden block, it should slide 2.5 meters, for example. So these are a question all you need to design, right? You cannot just pluck it from textbook and think that it is fulfilling that at that level. All right, so another question, suggest how the value is likely to vary with the rate at which the process is undertaken. So this one, what happens to Q and W in the case of an extremely rapid expansion? So the first part of the question requires you to derive a relationship, show that for a fully resisted. So very typical British question, they like derivation, right? They like student to derive. They give a scenario, they give you the starting equation. From that, they ask you to prove or to show that the equation is valid for what reason dan sebagainya, right? Then subsequently, then they can expand the question like this one. They said suggest how the n value for the second part for this one, and how the n value vary with the rate, and what happens to Q and W in the case of extremely rapid expansion. All right, so all these sort of question required student to engage with theory. That's why sometimes also it can be at the level of synthesis, may not be at the level of evaluation. But it's very hard to segregate where the boundary, where the line actually passes through. So that's why I always group the evaluation synthesis together. All right, so same thing, select an appropriate boundaries, system boundary, and applying the first law, determine the fraction by which the mass of the gas in a bottle increases. So you give certain things, you ask them to decide, right? So they will have to take a decision, what boundary condition they want, and then they obtain the particular solution. All right, so you give a lot of parameters. Assuming that the cost of electricity is 4 times that of natural gas, evaluate if the new system would be a better option. State any assumption made. So you give a system, now you ask them to evaluate those, right? So this may not be evaluation, this may be synthesis level. But still again, when you go through it, because the question may have some missing information, student needs to make a call Like just now tadi kan, the shaft, replacing of the shaft, right? So student will have to make some judgment. So then it can be evaluation. Okay, so this on a machine design problem. Appraise the proposal and show that it is viable. So you give them a scenario with so many parameters, and then you ask them to appraise the particular design, whether it's viable, not viable. All right, coming to an end. So basically when we talk about lots and hots, both are important, right? The lower order thinking skill, they are as important as the higher order thinking skill. So we cannot say that the lots are not important, right? And at the same time, when we want to set exam question, we must have a strategy. We must know that, because not some learning outcomes are low level, right? They are at the lots level. That's why if you set the questions based on learning outcome, you are able to set at which level that you want to push your question to. And also it comes back to setting the course learning outcome. So sometime at the early days when you set your course learning outcome, I'm sure you had workshops. Now in the workshops, normally they would encourage you to also use the Bloom's taxonomy to decide the level of your CLO. And the reason for that is because it ties in with the exam question. And sometimes when our CLO is all at lower level, maybe you are asked to teach a particular course, and when you look at the course learning outcome, they are all at the lower level. Takkan kita nak set low level question? Yelah, I know that I said you map it to your course learning outcome kan. But this is where you probably need to take it back to curriculum review and make a change in the learning outcomes when the learning outcomes is at lower level. Because you know it's not appropriate, right? So just don't accept it and set the question at low level, right? So maybe the topic coverage is there, but just the learning outcome is not done properly. Because when we set learning outcome, there should be learning outcome at the high level. Kalau tidak, how we set our question at the high level kan? All right, so that's the summary of the lots and the hots. And so in my concluding remark, so basically when we look at Bloom's taxonomy, it's a systematic process of thinking and learning, right? So we know that it builds, the knowledge is built from one level to another level, right? And that's where we set question, we use the same approach, and we want to basically test students to see if that they are able to apply their lower order thinking skill and their higher order thinking skill. Okay, so there are 6 levels for as far as Bloom's taxonomy is concerned. Creativity is important for engineering profession because we want to generate creative graduates. All of us, all university, they all brag about creating holistic graduate, creative graduate dan sebagainya, right? So how can we do that if we don't challenge our student at the course level, right? We don't give them the ability, we don't test their ability because we don't train them to apply critical thinking. All right, so we need to challenge them at the course level so that when they go out into industry, they can be creative, they can think, right? They can propose viable solution dan sebagainya. We have complex problem as the other approach that looks after the complexity of problems given to student and so on, right? And we have in our curriculum, as far as exam is concerned, we are trying to test their ability to apply their critical thinking skills. Because complex problem and critical thinking skills, they are two totally different approach to building or developing a holistic graduate. So two different approaches. So in many cases, mapping of CLO to BT levels were not planned, and therefore 90% of the time exam questions lacks the HOTS. I mean the middle one, okay. I mean most of us cover at the A level, but beyond the A, like just now IMEEK dah katakan, I showed you earlier the comment, level 5 and level 6. So most courses lack at that high level, and maybe it's not the lecturer's fault, maybe it's because the CLO is not at that high level. So when CLO is not at the high level, lecturer said, why should I set question at a high level, right? But if you are in that situation and you understand that you need to put forward challenging question at the high level, then you create question at the high level, although it may not link to that particular, I mean it links to a particular CLO, but because the CLO statement is phrased at lower level. But you can set question at high level. No one is stopping you from doing that. Okay, and as I said that as a panel, when we look at the final exam question, we want to look at questions that are challenging. We don't expect all questions to be challenging, but we want to see that there are challenging questions being asked to students, especially on their opinion, for them to discuss, for them to explain, benda macam tu, or redesign a system, that kind of thing. So we know that it is touching at the higher level as well. All right, so 6th level EAC. So now we all know EAC not just for Engineering Accreditation Council. It also, we can also remember that as far as the BT is concerned, Bloom's Taxonomy, E is the highest level, then A covers the 2 middle section, and then C is the lots, the comprehension level and knowledge level, so this lower. So we need to design questions to and ensure that they cover all levels of BT regardless of year of study. There are some argument that year 1, year 2 cover level 1 and 2 saja. That's not entirely true. Even at kindergarten level, you can cover all 6 level. But at the kindy level kan? So we can make questions challenging. And likewise for year 1, we need to challenge the student right from year 1, not wait until they come to year 3 or year 4. Okay, so you should challenge your student right at year 1, so that there is a continuously challenge, so that your program will continuously challenge the student in the quest to produce creative graduates. We cannot wait just 4th year and leave to the 4th year lecturers to challenge the student in their exam question. Tak boleh, dah terlambat. It has to be progression. At year 1, it's at year 1 level, then go to year 2, year 3, and when it goes to year 4, it's a high level, so questions that's set at that level is high, like mechanical vibration is high level. It's an application of dynamics, physics and so on, so it has to be at the higher level, a lot of mathematics involved. It's not low level. But of course you can ask questions that at the lower level within the context of that topic, that mechanical vibration, but there will be questions that will challenge students. Half page long, 1 page long, because a lot of things you want to write. You want to give them scenario, right? Because you are designing the question. Remember, you are designing, not textbook, not taking from textbook. You design the question, basically. All right, so with that, I'd like to say thank you. If there's any question, I'm able to take from the floor. Yeah. Tak ada lah, tak ada tinggi lah. Saya tahu ada yang kata level 5 is for masters, level 6 is for PhD kan. PhD mana ada exam? I understand. I know that there are some school of thoughts that thinks that level 5 and 6 should be covered at the masters or PhD level saja kan. But actually, when you look at it, when we talk about creative graduates, we want students to be able to apply knowledge. Where do you train them to have critical thinking if it's not at the undergraduate level? Of course, at the master's level is different. The master's level focus should be always 5 and 6 lah, master's level. But still you can cover the lower level as well, right? But a lot of the discussion, especially when we talk about the engineering accreditation, is at undergraduate level. And at the undergraduate level, we know that most of the students will ended up, they graduate, they pergi kerja, they don't go and do postgraduate. So we need to ensure that these people that comes out, they can solve complex problem and they can apply critical thinking at the highest level, right? And at that, when they go out and work, they are expect to propose viable solution to redesign system. So in the complex problem, don't talk about redesign system. So where do you test their ability to redesign system? It's at the undergraduate level, young level 6 or level 5. So kalau itu kita tak masukkan, then we are not preparing our graduates to be creative or holistic. So it's a different school of thoughts lah. I know some says that level undergraduate should only focus right up to level 4, but that's not entirely true, because we know that the industry wants graduates to be able on the first day to fly already. That's what industry wants, kan? Bukan still needs to be trained. And they got 4 years. They are 4 years with us, so we really need to build them up so that they are able to reach a state where they can apply critical thinking. And that's where the complex problem, the competencies, the characteristic, we need to embed that in our activities and in our assessment where possible, so that problems given are complex. That means unknown. But of course, not all problems can be unknown, because when we look at the Bloom's taxonomy, it goes from level 1 to level 6. So some of them is known problem, but they applying the knowledge. But at some point, you got to give problems where you want to test whether or not they are able to think. So it becomes complex. So actually, at the higher level, you can say that it looks like it's a complex issue, but you expect them to apply critical thinking. Okay, so it should cover at the undergraduate level as well. Yeah. Yeah, rata-rata, I think I also observed that a lot. But sometimes the 5 is also covering level 6. It's very hard to because you cannot just use the verb to differentiate that it's a 5 or 6 now. So sometimes the verb can be misleading, but the question, the way how the question asked, can also be at the level 6. So as long as you are at the level 5 and level 6 you know, whether you are in each or at the boundary, it doesn't matter. It is at the highest level. So our target is always, we are quite flexible when we look at it. If you get 10 panels to identify a question at what level, all 10 will give you probably 5. If it's a high level, they will tell you some will say 5, some will say 6. So it's very hard to draw that line. We cannot just use the verb to define, oh kalau nak synthesis pakai ni je. Kalau nak evaluate only this, tak boleh. And sometimes just one sentence justify your answer. The level 6 already, kan? Boleh because they need to explain Isnin. So here no calculation but the explanation. So it can be at that level. Yeah. So when in the explanation the student can draw flow chart, or the student can say how the whole thing can be put together. Yes, it can be at that level. Yeah. 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 What level kan? Yeah. Itulah, that's why I understand. But you don't need to follow, because that's to fulfill on paper. But as an academic staff, nobody said you cannot set for that CLO yang kata level 4. Nobody said you cannot set at 5 and 6. As a academic staff, we sometimes takkan you nak 100% student dapat A. You also wants to challenge the student kan. You teach the course, and you also want to design question that is at high level, kan? So you want to challenge. You want to challenge the student. I think that should be our main goal. Is that when we teach, we want to bring the student from week 1, when they have very little knowledge, to a point where they can apply solid knowledge to solve complex problems. So we want to give them high level problem juga. So although it is stated as C4, right, you can set at C5, C6. When you go through evaluation, the comment would be, oh, this is at high level. Itu je. You don't have to change it and bring it down one. It's when it is low level kita nak bawa ke high level, but high level nak bawa ke low level. I don't think any moderator would insist that you must lower it down. Nobody will insist that. tinggi. Tak. I don't think so. The panel normally they know they are not rigid. As I said, everything is not cast in stone. Yang what on paper is on paper. We set normally from what I know is set the minimum. So kalau kita C4, that means sekurang-kurangnya dia kena C4. Tak boleh C3 lah C4. Tapi kalau kita buat C5, C6, no issue. But of course, having said that, if you're teaching in a class, example, tutorial pun you bagi C4 level, then susah. Suddenly in final exam C5, C6, then it become the student will get the anxiety attack. Dia pun pening. Apalah cikgu ni bagi soalan tak gila punya soalan kan? But that's why I said that when you solve questions on the board, you must solve at high level as well, so student understand. If you don't go to that level, giving example and also giving tutorial, because you pandukan buku je, then you won't be at that level. Student dah boleh dapat solution manual, they don't even what symbol you use, they follow solution manual symbol. I kena banyak kali. Right? I say, I never teach you what is this symbol. And then I realized when I looked at it, it's from the solution manual. So they copy solution manual. So I say, you explain to me how you get this. Dia tak boleh explain. Copy solution manual. So I say, I never teach this. You go look at my notes. I never show this symbol. I don't know what symbol is this. Go and ask whoever the source of this symbol. I selalu cakap, pergi cari source. Source yang you dapat symbol ni, pergi cari dia orang. Go read my notes. My notes, how I showed you, I want you to look at that method and you solve according to that. So the student just want, you give problem, dia nak tengok solution manual, dia nak copy macam tu. Nak hantar without wanting to understand or wanting to learn. So I always tell student, answer not important. Answer is not important because answer in our marking scheme, answer carry 2 marks, 3 marks tu je. Yang working dia yang penting kan. So they demonstrate understanding through that working, the working process. So minimum 4 tak apa, but you can set at 5 and 6. And I'm very sure no panel will tell you that, oh, you cannot do that and so on. Your paper say 4, tak ada lah. I mean, we are not rigid. We are not rigid. Of course, you say 4 and you go 3, then you will be commented lah. This is low level. You kena sekurang-kurangnya level 4. But if you are level 5 and 6, that's fine. Yeah. Yeah. Boleh? No problem what? No problem. But that's why I said you plan, you can have a question, part A, part B. Part A you bagilah low level sikit, definition ke apa, then part B you ask at the higher level, okay what? Nobody say cannot what? So it's just that your instrument, your process may be rigid. Itu je. Maybe ketua jabatan yang cakap kena 4. I tak tahu.
Tapi roughly kalau untuk year 1 and year 2,
yeah. Boleh upkan, tak ada masalah. Sepatutnya even year 1 pun dah boleh masuk ke level 4, level 5 pun kalau nak. It's not a problem at all. It's just that's why I said, it's just that the system, you should always take it as minimum. So the system says like C3, okay, minimum lah. Tapi kita sebagai pencara, we know that we want to challenge the student. So how to challenge the student in final exam? Takkan kita nak bagi sampai semua C4, all our questions C4, then there's no challenge lah. So the whole idea is to challenge the student. And that should be our call as academic staff when we set, because when we give example also, we want to give high level example. Takkan kita nak bagi level 4 punya example je selalu. Kita nak student tengok soalan macam mana, confuse punya soalan, complex punya soalan dan sebagainya, open-ended question, how is it and so on. So if you don't train student in a classroom, memang when you set exam question, they will struggle. And I know you terikat dengan you punya this thing. Oh, sama juga. I think because student will have to balance the time. For example, your exam is 3 hours. They answer 4 questions. So roughly got 40 minutes kan. Roughly got 40 minutes. So within 40 minutes, of course, you need to design a question that student can solve within 40 minutes, kan? That should be the gauge lah, the way how you put it, because all the exam questions ada answer. There is no like tak ada answer, ada. Yang tak ada answer like the evaluation, basically the right answer is you akan ambil judgement on what student say. Depend on apa student tuliskan, then you bagi markah, your discretion. It's your discretion, kan? So your solution, in your marking scheme, you said 5 marks is given based on student rational on the topic and what. So you kata macam tu 5 markah bagilah. So but the time we must always take into consideration lah. Yeah. I remember when I was student, ada soalan panjang-panjang sampai 1 page, 1.5 page. Masa cukup. Kita strategize. First class student boleh buat. Strategi, kita jumpa je soalan, kita tahu, kita time, kita tengok. Kita tahu yang 30 minutes finish, so we got 15 minutes lead time. Second question, we build up the time. Memang tulis non-stop lah. Non-stop. So nak kata tak boleh, boleh. They set question at that level. Yeah. No. Not really. It depends on the question itself. The question, the depth you read. So when you baca, then you know, okay, there's depth there. I don't look for keywords at all in when I do my evaluation. Sebab they cross tau. Some keyword discuss can also use at application level. Discuss can use at evaluation level. Takkan kita nak rigidkan keyword saja. I baca soalan. I see the question. No, I see what you ask to find, what you give the student, and I see whether or not that is what level. I selalu tengok macam tu. So I know from the question that is given whether you are level 4 or level 5 or level 6. So kurang-kurangnya kita nak tengok satu soalan lah, satu or couple of sections, subsection you tanya at the high level. It's okay lah. You are challenging your student lah. So maybe like, okay lah, year 1, year 2, you tak ada satu soalan yang level 5 or 6, tapi you ada sub. Sikit-sikit markah you bagi. So you ask at high level. Okay, what? Yeah, of course, can be counted. So of course when you declare it level 4. But if you declare by section, so 1A you level 4, memang CLO 2 level 4, betul lah. But 1B you letak 5, level 5, letak level 5, takkan moderator nak kata tak boleh. Tak, you memang memenuhi level 4 lah, so most minimum lah. Kita tengok as minimum lah, as minimum level. Oh, macam tu. Yeah, I think one-to-one mapping is a good approach lah. That's fine. Tapi sebenarnya CLO tu boleh dua CLO boleh map kepada satu PO tak salah. Tapi kalau dah approach dah diambil untuk one CLO to one PLO, so kalau 3 PLO, so PLO akan tentukan berapa CLO lah. Nampak macam tu kan? So kalau dia kata 3 CLO, 3 PLO, 3 CLO. But actually sekarang kita dah we have graduated already from this OBE approach. Dulu very rigid, but now we know already. You can have 5, 6 CLO pun tak apa. But even because you can have 2 CLO to 1 PLO, 3 CLO to 1 PLO pun sama. Tapi same CLO to the another PLO pun boleh, tapi differentiation dekat assessment. So asalkan you boleh tunjuk is direct and explicit, is fine. But in your case, if it's 1-to-1, then CLO tu you kena pecah lah, kena cover 2. Macam tadi saya tunjuk satu CLO you tick at you tick at C2 and you tick at C5. Artinya ada dua soalan lah. Macam you know, the end outcome bukannya mengikut chapter. So sometimes one CLO combine 2 chapter or 3 chapter, dia combine untuk pelajar memenuhi outcome tersebut, dia kena tahu 3 chapter macam tu, kan? So the approach may be a bit not correct lah kalau pandu kepada chapter. Tak boleh macam tu. Because CLO normally is a combination of theories with a specific outcome. And that's why normally we have 5 CLO. Typically, most program is 5-6 CLO. Except for latihan industri, IDP dengan FYP can go as many. And the good way to set the CLO for all these IDP, FYP, kita pandukan kalau kita ada 6 CLO, kita ada 6 PLO. So senang kita pandu satu-satu, so direct. So because these are culminating anchor courses, they should be able to cover as many PLO. So you have 7 PLO, you wujudkan 7 CLO and one-to-one mapping, senang. Tapi untuk subjek biasa, the core engineering, you can have up to, walaupun 3 PLO, baguslah. Memang kalau the approach is to link to only 3 PLO, sebab tak boleh banyak pun. So link to 3, okay. Tapi CLO boleh lebih daripada 3. 4 pun boleh, 5 pun boleh. Asalkan mapping tu dibuat dengan cara betul lah. Is linked to that particular PLO. So it's quite flexible actually when you come to all this. Even EAC pun tak berapa serious lagi on, they don't go on counting and see how this thing, they assume that kita dah graduate.
Knowledge sharing, alright. So officially we close the session, okay, and then we go for the summarize from the prof lah. Okay, and the Hafiz mana? Mana? Okay, after that we go for the lunch and kita dismiss dah prof. Okay, so prof, ke prof nak rehat dulu ke apa? Ke prof nak terus nak summarize apa-apa, ataupun saya boleh display apa yang saya dah tulis? Boleh. Saya display dulu